Hi, welcome to the Database Level 200 lesson. My name is Sanjay Narvekar and I'm a product manager in the Oracle Cloud Infrastructure Field Enablement team. I will be taking you through the lesson today. Here's our safe harbor statement. The gist of this is to let you know that anything you see in this lesson is intended for information purposes only and may not be incorporated into any contract. In the database level 100 lesson, you learned about the fundamentals of database systems in Oracle Cloud Infrastructure, starting from the different choices to the deployment options of databases on Oracle Cloud Infrastructure. In this lesson, you're going to be getting familiar with the command line interface that you can use to manage and deploy databases on Oracle Cloud Infrastructure. And then you'll also look deeper into the backup and recovery capabilities of databases. And from there, you'll be moving on to learning about troubleshooting database backup failures and also learn about different database migration methods to move data into Oracle Cloud Infrastructure database systems. And then finally, you can see how the Oracle Cloud Infrastructure database systems can be used to enable maximum availability architecture. The database command line interface, also known as DBCLI, is a command line interface available on bare metal and virtual machine DB systems. So what this allows you to do is you can connect to the database server using SSH and then use the command line interface to perform tasks such as creating database homes and databases. From a scope of DBCLI commands perspective, you can use it on the whole database system across all homes. You can use it to manage backup configurations and operations, database configuration and operations, storage configurations, and so on. You'll find the DBCLI on every OCI database system under /opt/oracle/dcs/bin folder. And you need to run these commands as the root user. Oracle Cloud Infrastructure will maintain logs of the DBCLI command output in the dcs_cli.log and dcs_agent.log files, which is found under the /opt/oracle/dcs/log directory. One quick thing to note is the database CLI commands and most parameters are case sensitive and they should be typed as shown in this example. So you started off with dbcli and then give the command and then follow it up with the parameters. So one example for the command is a verb object combination such as create database. And for the parameters, you precede the parameters with two dashes, for example, dash dash help. Oracle frequently keeps updating the CLI utilities. So we recommend that you update the DBCLI whenever possible. And the way you go about doing that is by executing the command CLI ADM space update dash DBCLI. So this command will download the latest version of the DBCLI and install it on your database system. On this slide, you also see examples for the DBCLI commands that you saw in the previous slide. So in the first example, you're creating a database called CRMDB of database class OLTP and using the ODB2 database shape. In the second example, you're creating an Oracle database home version 12.1.0.2. If you go to the link listed at the bottom of the slide, you'll find more information on the DBCLI commands and how you can use them. So then we look at the database sizing templates. So this template kind of goes along with the DBCLI create database command. And basically this template determines the shape of the database that you're going to be deploying, and this will let the CLI command know how to provision the database with the right amount of CPU, RAM, database processes, etc. And our recommendation is that you choose the OLTP templates if your database workload is primarily online transaction processing or OLTP, and to use the DSS templates if your database workload is primarily decision support or DSS. You can also use the in-memory templates if your database workload can fit in memory and can benefit from in-memory performance capabilities. Yeah, you can go to the link at the bottom of the slide to find out more information on the various sizing templates that are provided by Oracle Cloud Infrastructure for deploying your database using the DBCLI create database command. We now look at backing up to Oracle Cloud Infrastructure object storage from the database systems. So there are two ways of backing up your database into the cloud object storage. The first one is using the console, and the second one is using the API. Now, to use the cloud infrastructure console or the REST API, you need to have the right kind of identity and access management policy, which is going to be created by an administrator and assigned to you by associating your user account with an identity and access management group within Oracle Cloud Infrastructure. So then you look at the prerequisites for backing up your database to OCI Object Storage. The first one is your database system's cloud network or VCN must be configured with either a service gateway or an internet gateway. And second one is your DB system must have connectivity to the applicable Swift endpoint for object storage. And then this is kind of a given when you're backing up database into any backup library. Your database needs to be in archive log mode. So ensure that your database has been configured for archive logging. Then you need to ensure that /uo1 directory on the database host file system has sufficient free space for the execution of backup processes. And this goes without saying, if you do not have enough disk space on /01, your database can stop running because it will wait for you to free up disk space, and only then you can continue using your database. And this is an error you can run into quite frequently if you do not do space management on the /u01 directory. And finally, the last bullet there is the Linux operating system users .bash profile for the Oracle user should not include any interactive commands such as ORI-env or one that could generate an error or warning message. And typically what we have seen is sometimes these bash profile scripts waits for an input from the user, and this can lead to shell scripts just waiting for input and not doing what they should be performing. So make sure that your bash profile script does not include any interactive commands. Now you can find more information on backing up databases in that link below. And the last couple of points in this is you need to make sure that you do not make any changes to the wallet location entry in the SQLnet.aura file, and also do not make any changes to the rman backup settings by using the standard rman commands. Now when you use the console, you can enable automatic incremental backups, create full backups on demand, and view the list of managed backups for a database. You can also use the console to delete full backups. For a backup operation to run, your database and DB system must be in an available state. Oracle recommends that you avoid performing actions that could interfere with availability, such as patching or data guard operations. If for some reason an automatic backup operation fails, the database service retries the operation during the next day's backup window. And if an on-demand backup fails, you can try the operation again when the DB system and the database availability are restored. When you enable the automatic backup feature, the service creates daily incremental backups of the database to object storage. The first backup created is a level 0 backup, which is basically a full backup, and then level 1 backups are created every day until the next weekend, and these level 1 backups are basically incremental backups. And every weekend the cycle repeats, starting with the new level 0 backup. Note that the automatic backup process can run at any time within the daily backup window, which is between midnight and 6 a.m. UTC. Automatic incremental backups are retained in object storage for 30 days. After 30 days, the system automatically deletes your incremental backups. One note that you can see here is you can enable automatic backup feature on a database with a standby role in a data guard association. However, automatic backups for the database will not be created until that database assumes the primary role. Now let's look at on-demand full backups. You can create a full backup of your database at any time unless your database is assuming the standby role in a data guard association. When you terminate a database system or a database, all of its resources are deleted along with any automatic backups. Full backups, however, remain in object storage as standalone backups, and then you can use a standalone backup to create a new database. Let's now look at recovering a database from object storage. We will now look at recovering a database from a backup stored in object storage. You can perform this recovery of a database using the console, API, or by using RMAN. you will need the appropriate identity and access management policy, and this will allow you to use the console or the REST API within an SDK or CLI to perform these backup operations. From a prerequisites, your database system's cloud network must be configured with either a service gateway or an internet gateway, and your database system must have connectivity to the applicable Swift endpoint for object storage. You can use the console to restore the database from a backup in the object storage that was created by using the console or the API. Now, in terms of the options for restoring a database, you can restore the database to the latest backup, or you can specify a point in time or an existing system change number or SCN. You can also create a new database using a standalone backup. I have provided a link at the bottom of the slide where you can find more information and do a deeper dive on the database restore process. You need to note that the list of backups you see in the console does not include any unmanaged backups. And when I say unmanaged backups, I mean backups that are created directly by using RMAN or DBCLI. Also, restoring a database with DataGuard enabled is not supported. You need to first remove the DataGuard association by terminating the standby database before you can restore the database. You can use a standalone backup to create a database in an existing database system or to launch a new database system. You can also recover a database backup or an RMAN backup stored in object storage. Let us now look at troubleshooting database backup failures. Database backups can fail for a variety of reasons. Typically, a backup fails because either the database host cannot access the object store, or there are problems on the host or with the database configuration. The first step in troubleshooting this is to determine the problem. Now, you can navigate to the console and get to the database that is having these issues and look at the status of the backups. Typically, this will be a status of failed, or it'll be hung in the backup in progress or creating state. If the error message does not contain enough information to point you to a solution, you can use the database CLI and log files to gather more data. Now, the next section in this slide talks about steps to identify the root cause of the backup failure. In brief, this involves the database administrator to log in into the DB system as the root user and to run a few DBCLI commands to determine the job which had the issue and then get to the error message by doing a DBCLI describe job. And once you find the job ID of the failed backup job, you can look into the RMAN logs if the issue is determined to be an RMAN issue. Please note that if you are having a database backup issue on a two-node rack database, then you need to perform steps 3 and 4 on both the nodes. In certain cases, database backup failures can occur due to the database service agent issues also. So in the event this happens, you will need to restart the DCS agent if it has the status of stop or waiting to resolve a backup failure. In the next section, you'll see the steps that you need to perform to restart the database service agent. Backup failures can also occur due to Oracle clusterware issues. As you know, Oracle clusterware enables servers to communicate with each other so that they can function as a collective unit. Occasionally, you might need to restart the clusterware program to resolve a backup failure. In the next section, the steps for restarting the clusterware is provided. Database backup failures can also occur due to the object storage connectivity issues. When you back up your database to Oracle Cloud Infrastructure Object Storage, it requires that the database host can connect to the applicable Swift endpoint of the object storage. You can test this connectivity by using a Swift user. The next section gives you the information on how you can ensure that your database host can connect to the object store. Database backup failures can also occur due to host issues. One or more of the following conditions on the database host can cause backups to fail. And we already saw that the first one can be because of interactive commands in the bash profile file. This basically can cause the scripts to hang because the shell script is waiting for an input from the Oracle user. The second one, which we have already seen before, is the file system is full. On the Oracle Cloud Infrastructure database systems, backup operations require space in the /u01 directory. As a database administrator, you need to ensure that there is sufficient space on that folder at any given time so that the backups can run properly, and also make sure that the database doesn't hang because the archive log destination is full. Database backups can also fail due to the incorrect version of the Oracle Database Cloud Backup module. To get past this issue, make sure that you're always running the latest version of the Oracle Database Cloud Backup module. Backups can also fail due to changes to the site profile file or the glogin.sql file. So Oracle recommends that you do not modify this file for databases hosted in Oracle Cloud Infrastructure. Failures can also occur due to database issues or the database not running during backups. Please ensure that the database is active and running when the backup is in progress. I have provided a link below which will give you additional information on troubleshooting database backups and also to ensure that the database is active and running when your backups fail. In addition to the causes for the database backups to fail, which you have seen in the previous slide, database backups can also fail due to the archiving mode set to no archive log, or a stuck database archiver process when flash recovery area is full, or due to temporary table space errors. Editing certain RMAN configuration parameters can also lead to backup failures in OCI. Take a look at the link provided there for RMAN configuration settings that should not be altered. The RMAN retention policy configuration can be the source of backup failures. Using the redundancy retention policy configuration instead of the recovery window policy can lead to backup failures. Be sure to use the recovery window of 30 days configuration. RMAN backups fail when an object store wallet file is lost. The wallet file is necessary to enable connectivity to the object store. So please confirm that the object store wallet file exists and has the correct permissions. Incorrect TDE wallet file can also cause issues with the backups. Incorrect state of the wallet file can also lead to issues. So ensure that these files are in the proper state and in the proper location. Here are some more bullet points on the transparent data encryption wallet file. Please follow these to make sure that you're not having any database issues due to this file. The last bullet there is about the missing auto login wallet file. This file, which is the cwallet.sso, can cause backups to fail if it is missing or if it has incompatible file system permissions or ownership. So ensure that it has the right permissions and it is found in the location that the database is expecting it to be in. Other causes that can lead to backup failures is the unmounted common store mount point, or the database is not properly registered with the DCS agent. So make sure that you are not experiencing any of these symptoms when troubleshooting the database backup failures. On this slide, you'll see information on how you can collect database and diagnostics information to resolve errors. We will now look at the methods for migrating your databases to Oracle Cloud Infrastructure, as well as the factors that you need to consider during the migration process. You can migrate your on-premises Oracle database to an Oracle Cloud Infrastructure database using a number of different methods that use several different tools. The method that applies to a given migration scenario depends on several factors, including the version, character set, and platform endian format of the source and target databases. Not all migration methods apply to all migration scenarios. Many of the migration methods apply only if specific characteristics of the source and destination databases match or are compatible. Moreover, additional factors can affect which method you choose for your migration from among the methods that are technically applicable to your migration scenario. Some of the characteristics and factors to consider when choosing a migration method are preference for certain tools, import-export, data pump, RMAN, etc., on-premises database version, database service database version, size of the database, connectivity between your on-premises and the Oracle Cloud Infrastructure data center. And the last one there is the bulk data transfer methodology for migration. Typically, we ask customers to look at this option when their databases are very large. When you want to transfer database backups to Oracle Cloud Infrastructure Object Storage, use the following guidelines and options to help you plan and estimate the transfer. The table that we have provided below gives you a high level guidance based on theoretical minimums from over the internet data transfer time calculators. You can start with these estimates to evaluate the time it might take to transfer your data, but then please ensure that you test for the actual numbers based on your data volume, network bandwidth, and network reliability. Note, however, that if you're uploading data that takes longer than 1 to 2 weeks, consider using the data transfer service option. This slide gives you information on the data transfer options. We will now look at the incremental backups considerations. Based on your data volume, network bandwidth, and network reliability, you can also upload incremental backups to object storage by using any of the preceding options. As long as backups are complete and consistent, you can use a combination of transfer options staggered over a period of time to transfer the required backups to the target bucket. For example, say that you transferred the bulk of your data by using the data transfer service. The incremental backups that occurred since the last level 0 or level 1 backups shipped via the data transfer service can be uploaded by using different methods such as the OCI CLI or rclone to the same target bucket which has other level 0 or level 1 backups. As a best practice, we recommend that you do not upload the TDE wallet files and backups to the same location. We will now look at the maximum availability architecture for Oracle databases on OCI. On this slide, you will see the building blocks for maximum availability architecture that is available in OCI. For our database system components such as bare metal and the virtual machine, whether it is a single instance or a rack, or the Exadata cloud service on OCI, we allow database backups to object storage, which is either manual or automatic. And note that these automatic backups are copied across the availability domains within a region. In the case of the OCI bare metal instances, you have the ability to deploy active data guard or data guard and replicate your data within a region across availability domains, or you can manually configure VCN peering across regions and set up active data guard or data guard to replicate your backups across regions. In terms of high availability, the OCI database systems running on virtual machines and the Exadata systems can have rack instances. When deploying rack instances on VMs, note that the VMs are in separate fault domains, and this will protect the database from local server failures. We can now look at the maximum availability architecture database deployment. All databases that are deployed in OCI DB systems are provisioned with maximum availability architecture parameter configurations. And these databases can be provisioned with the simple user interface or CLI or REST interfaces. Over here, you will see uh, typical recommendations for different levels of maximum availability architectures for the OCI database systems. For the bronze level, you can have a single instance database being backed up to the database backup service. One level of silver, which provides high availability for your databases, is to deploy a rack database and back it up to the object storage. An alternate version of the silver maximum availability architecture deployment is to deploy the primary and the standby database using data guard across different availability domains. And then the last one in this slide is the gold maximum availability architecture deployment model, where you are deploying a rack database in region 1 and a standby rack database in region 2. We shall now look at the bronze model, which is a low cost maximum availability architecture solution for customers that can tolerate a higher recovery time objective and recovery point objective. This model basically requires that your single instance database is backed up to object storage, and you're then replicating your object storage to a remote data center. In this slide, you're looking at the various capabilities provided or enabled by the bronze maximum availability architecture for your databases running in Oracle Cloud infrastructure. Let us now look at the silver maximum availability architecture deployment method, which involves HA with fast failover. This enables recovery time objective of seconds for server failures, and basically this involves an active clustering of the database with Oracle RAC. These nodes are active at all times and will give customers the ability of a real-time failover. These rack instances enable zero downtime for rolling maintenance across rack instances. This slide shows you the various capabilities that is enabled by a silver maximum availability architecture or your database systems running in Oracle Cloud infrastructure. We'll now look at the second option for the silver maximum availability architecture deployment method, which involves high availability with data guard fast start failover. In this method, you're running a single instance database in region 1 and you are replicating this database using data guard to another availability domain in the same region. And Oracle recommends that you use active data guard and its real-time apply and auto block repair functionalities for your database. This slide shows you the various features and capabilities enabled by the silver option 2 maximum availability architecture. We now look at the gold deployment method for your databases, which provides you with an RTO of seconds to minutes and RPO of 0 or near 0. This method involves deploying a database in a region and using active data guard to replicate the data to another database which is in standby mode in another region. For best practice, we recommend using active data guard, which will enable the standby database for reporting or to test issues in production on the standby, and finally for automatic data corruption protection. Having this kind of architecture will provide you minimal downtime for database upgrades using the DBMS underscore rolling or transient logical standby mechanisms. This slide shows you the capabilities provided by the gold maximum availability architecture deployment method. And finally, when you deploy the gold maximum availability architecture for your databases, it provides you comprehensive high availability and data protection. And as you can see from the capabilities listed here, a majority of these tasks can be done with zero downtime and with zero data loss. This slide shows you the OCI deployment model for your databases. When you enable this kind of an architecture, you can provide high availability, data protection, and fast failover for your databases across the availability domains. Oracle Cloud Infrastructure uses a very fast network, and as a result of this, you can have DataGuard synchronous method of transporting your logs with the transfer time under a couple of milliseconds between availability domains. Please note, however, that the DataGuard fast start failover is manual. Currently, VCN peering across regions is enabled between Phoenix and Ashburn, and also London and Frankfurt. Since you cannot provision database across regions, you cannot create DR architectures using cloud tooling, and this architecture has to be manually configured. In today's lesson, you learned how to use the database command line interface on the Oracle Cloud Infrastructure database systems. You then saw how you can back up a database and recover from a database backup, as well as troubleshoot database backup failures. You also learned the different database migration methods to move data into OCI database systems. And then finally, you looked at the maximum availability architecture capabilities of OCI for DB systems. Here are some additional links to articles and blogs that you can use in continuing to learn about Oracle databases in Oracle Cloud Infrastructure, as well as maximum availability architecture, reference architectures, and database migrations. I hope you enjoyed this lesson, and thanks for spending your time today with me. Have a great day.